let's talk about the presentation that you did yesterday, because that was awesome. And it was evident that there was a lot of research, it was very thoughtful, like the amount of like effort that you put into it. So
Sure.
Maybe we could start about kind of like your approach to putting together this framework for assessing rollups.
Sure, yeah. So let me give it a little bit of context, and then I'll tell you about how we did it, and sort of what we want to do still, and how we think it can be helpful. So we being QuantStamp, we got a grant from the Ethereum Foundation to study the security of rollups. Obviously they're pretty popular these days, but they're all very custom in a lot of ways, right? There's a push towards, certain common features like EVM equivalence or things like this. But the reality is each rollup is at different stages of development, and Vitalik's got a nice post about, some actual stage classification. But beyond even that, we'd looked at this in the past and saw that, a lot of them have roadmaps which don't necessarily correspond to those stages, perhaps. And they were sort of advancing at different paces in different places. And so we thought, well, that's definitely going to cause some risk, right? Like, people are going to assume something about these systems, and those assumptions are at least occasionally going to be wrong. And we wanted to figure out how we could help the community, make fewer wrong assumptions, and make sure that as a result, the systems that they are using are ones that they're comfortable with in terms of risk and trust.
Before we dive into like some of the assessments that you put together, could you just kind of rattle off a few common assumptions that we tend to make as users or developers of these rollups?
Yeah, I mean, like, is it at all possible that my funds get locked, right? Is it always going to be the case that there's a state proposer online to post a new state route? Is it, the case that my transaction will always be pushed through, or will it always be pushed through in some certain time frame? These are the most common ones, right? And in some cases, the answer is definitely yes. There are systems out there that have layer one like inboxes that the sequencer is sort of supposed to pick up from after a certain time frame, so you can avoid censorship in this way. And in some cases, that also lets you withdraw funds in some nice way. But if you're new to this space, you sort of think that it's like Ethereum itself, where you submit a transaction, provided the gas is sort of sufficiently high, it's going to go through eventually, right? Maybe it'll go through very quick if you pay a lot. Maybe it'll take a little bit longer if you are cheap and you sort of go with the bare minimum. But rollups, fundamentally, because of these other components that they introduce, don't have that by default. You have to build that in, because the liveness assumptions is that, like, as long as Ethereum, where the smart contracts for the rollups are running, is running, then you sort of assume that the rollup should also be running. But if the smart contract is blocked waiting for something to come from a component that's offline, like a sequencer or a state proposer, that assumption is not there. So you have to actually build that into the smart contracts and the rollup design itself. And I think a lot of people still take that for granted. I think that's probably the biggest.
Awesome. Okay. So that gives us a few of the common assumptions. When it comes to looking at these rollups, and then how to think about, like, okay, if these assumptions are necessary, and if they are, like, how to make them as like safe and reliable as possible, and then even if they're not necessary, how to remove those assumptions completely.
So I mean, I think a lot of the assumptions are sort of fair in the sense that the perfect rollup design will probably have a lot of them countered, right? There will be things like escape hatches, and there will be sort of ways to handle failures of these components, right? So you could, for example, have a timeout saying, if you haven't seen a block come in from the layer 2 in a week, anyone gets to propose a block, in which case, in principle, assuming no hardware requirements are really high, you can be that person, and so you can sort of get your own funds at least, right? And you can also maybe serve the community, depending on, if there's an incentive to do that, or if you want to do that. So these are sort of, I don't know if they're required assumptions, but sort of the design space doesn't prohibit you from making these assumptions in the sort of ideal space. The problem is these rollups are pretty new. Most have been in development for quite some time, and they're still not complete. If you look at sort of a complete roadmap, no rollup out there, I think, is on their website saying we're done. Mm-hmm. Like, this is it, we're done. We're not making any more upgrades. Everything is good. Everything will always be what you want it to be. they're all usually missing some level of functionality, right? If you look at, some of the optimistic ones, they don't all have fraud-proof systems. If you look at the ZK ones, they're, better at proving every sort of block, but they're not necessarily having escape hatches, right? So it's very, very rare that you find one with a lot of them. So, I think there are a couple out there that are pretty complete. And certainly if you look at L2Beat, it's a great website, by the way.
We'll link it.
Yeah, please do. They have this pie chart, which is where we started this framework. I'm sorry to go back to the framework for just a second. And I think there's only a couple on there that are fully green, which means they're sort of guarded against all of these assumptions. And so, that's the ideal world. Everything is always green there. But as I tried to explain in some of the framework issues, that's not totally sufficient. That's not to say that L2Beat's done a bad job. There's just a lot that these systems can do, and not all of them are sort of big security risks. Some are very minor, and some of them are assumptions that aren't common. And if they're not common assumptions, of course, it doesn't make sense to always present that information in a very clear way.
There's a lot more to these roll-ups than you can present in a pie chart.
Yeah, for sure. So, to go back to the framework then, when we started looking at it, we wanted to see exactly what L2Beat was missing, because, people would say, well, why is someone building a new roll-up if, these ones already exist? And starting to ask the questions of why, there's obviously reasons for some people to do it, they just want their own chain or they want money or whatever. But in other cases, it's because, they think they can do better. And why do they think they could do better? Well, because some roll-up is missing some functionality and feature, or, they're not being fully decentralized, or they don't have a plan to be decentralized, or things like this. And so we started looking at those differences, and specifically the security assumptions, right? It was sort of right around the time where I think on one of the ZK chains, someone had made a contract deployed a contract that it was supposed to work just out of the box, and the gas limit had changed on it. I can't remember if I think it was ZK Sync. I don't know if I should name drop them and offend them, but I'm not trying to throw them under the bus or anything like that. It's just, it happened, and they sort of need the project who deployed the contract ended up getting some funds locked in it, and sort of ZK Sync needed to step in. If it was ZK Sync, I apologize if it's not. I can send it to you later with the specific instance. They had to step in and sort of recover the funds in part. They had to give a hand in doing that. And for big projects and early stage roll-ups with a vested interest of, progressing to be really mature systems, that is totally fair. But if you could imagine, you don't have the clout, or you didn't raise millions of dollars, you only raised maybe a couple $1,000 on your project, but maybe that's more than you've seen in a long time, or, that's all you need for your project to get off the ground, maybe someone wouldn't have been so accommodating, right? You'd like to think ZK Sync or whoever was, doing that would still step in. But if they were too busy or they didn't care, you would have been sort of out of luck. You would have had to do something different, and you probably would have lost some users from it. And that's not good, because now these roll-ups have some control over not just their own security implications, but also, they're affecting projects launching on them. And so these questions, specifically ones that weren't present on this pie chart, is something EVM compatible? Is this gas pricing a little bit different? Are there other things like operational concerns? So, ZK Sync, they did a great job and they responded to that. But, in a world where we have 20 or 30 or more layer 2s, which is, from the looks of it, going to be happening, since we're already at probably 20 on L2Beat.com.
Yeah.
Not all of them are going to have a good BD track record. Not all of them are going to be able to provide that support. They're going to be stuck dealing with either bigger clients who they care about more, or just, overloaded with other things, or they just won't care. Some people, we saw really bad, things in the space before. We saw people rug people all the time. We saw NFTs that were just in it for the quick cash grab. I wouldn't be surprised if there's going to be some cash grabby type roll-ups out there, right? I hope that's not the case. I hope everyone builds one with a really good, intent and reason, because these are more complicated. So it'd be kind of impressive if someone did a long scam like that. But on the other hand, because they're so useful, we don't want to sour this. I'm not saying NFTs weren't useful, but flipping JPEGs got boring at some point, and I won't share too many opinions on that. Adding more block space so we can scale Ethereum is less boring, right? Maybe it's boring at some point from sort of the business point of view, but technically it's still very interesting, and technically it's still very necessary. So even if it is boring, well, it's necessary. So you've sort of got to do it, right?
Yeah. And when it comes to, I think that is probably a word of advice to developers who are building at the app layer, which is choose your rollup wisely.
Yeah. Yeah. So I mean, the whole point of the framework, and I'll send you the link to the framework so you can link it too. The whole point of the framework is so that people can make these decisions. And right now, it probably needs a little bit more work. We need to make it more interactive and a little bit less dry, because it is fairly long and it's not something you can complete in 3 minutes. It's going to take you some time to really evaluate this. But what we found was, without even this dry, lengthy thing, people had no real idea of why to choose one rollup or another. They'd often go where TVL is locked up, and that's not necessarily a bad thing. But that TVL should also be there for the right reason. And for all you know, the TVL is not there because they did their due diligence. They just aped into it or whatever. And we wanted to provide a way to say, this one seems like it's probably not going to screw you. And, if it is going to screw you, here's the ways it can kind of do that, right? Because we're a security company. And ideally, we would review every one of these rollups in depth and say, this is a bug. Please go fix it, or tell me on the roadmap when you're going to solve it. But there's a lot of rollups, and they're really slow. Like, they're not slow to operate. They're slow to review. They're big, complex systems. So we can't do that. And so if we can make this open so that other people can do it, maybe it's not as good as having an expert review it, but it's something. And if that just protects even a handful of users, it was well worth the time and effort and the money to do it.
Okay. I have a couple more questions on the framework, and
Sure.
one specific question about a security assumption that you've mentioned.
Sure.
And we'll switch gears into some higher level concepts. So the specific question about one of the security assumptions is an escape hatch.
Yeah.
I heard you mention it last night, and then in this conversation now. So what is an escape hatch, and why is it so important?
So yeah, an escape hatch is usually a functionality built into the layer 1 smart contract of the layer 2 system itself that allows you to withdraw funds or other assets that are important, even if the sequencer or state proposer goes down. So usually what happens is, the rollup is functioning for some period of time. You bridge some things into the canonical bridge. Everything works out. But if something goes bad with that rollup, you still want to be able to get your funds out of this.
And when you say get funds out and withdraw, that means basically get to a different, safer chain.
No, I mean, it could be a migration to another state, but chain. But usually, it's withdrawing back to the layer 1, like the layer on which the rollup has been built.
And for rollups that are built from Ethereum-centric architecture, that would be back to Ethereum.
That'd be exactly
okay.
That. Yeah. So I mean, we've published one paper on these ideal properties, and it might be nice to actually escape from, say, Optimism to another Optimism chain if something were to go wrong, because it might be more efficient. What we're scared about, this is off topic of the specific definition, but what we're sort of scared about is if someone needs to use them. Thankfully, no one has really needed to use this, and it's sort of a feature that if everything goes right, no one needs to use. It's almost a waste of engineering time. Almost, if everything else is good. But you should have one. I will definitely recommend always having one if it's an option. They are difficult to build and that. But we are also, I'm personally scared of the situation where someone actually needs to use one, and all of a sudden, everyone is trying to get off the chain at the same time. You're going to get this congestion on layer 1. It'd be a gas war to get your funds out. And this doesn't seem all that implausible because, if you actually see a layer 2 with massive adoption, and then if it did, God forbid, crash, some people would want their funds out really quickly for obvious reasons. They just like to have their own money because things could maybe go worse. So yeah, that's the functionality.
Yeah, and we don't. I mean, we like to think of things as self-custodial or non-custodial, and when funds can get locked up in a chain and we don't have control to move our funds anymore, it's almost like this chain is custodying our funds, but the funds have to live. It's this almost weird social connection that we have where money can't really live in a silo because then it's not used to exchange for anything. It's got to kind of have this social connection to other money for it to be useful.
Yeah, so I think on Twitter there's been a couple conversations where people have said, well, the layer 2 chain itself is actually its own blockchain and it doesn't need to be sort of tied to the layer 1, and so the escape hatch maybe isn't strictly necessary. And I think technically that might be true, but if you have an under collateralized chain because you don't have the the cache available because it's locked, and you sort of socially consensed your way, like made a consensus to switch what the chain is. Maybe technically that was feasible, but socially, if I don't have the same ETH, it's a different copy of ETH. It's not very useful to me right now. Maybe there's a world where that is useful. I would guess most of the time that's not the case. I think this was a conversation by John Charbonneau and Kelvin Victor versus sort of like Togrel from Scroll, where I think the Scroll side was bridges are essential and critical, and the optimism was, well, it's just another chain, and there happens to be a really nice bridge that's very useful, but the bridge is not critical. But I would say the bridge is somewhat critical because that escape functionality is what makes it more than just a little bit of a bridge. It's sort of a bridge with this extra guarantee that if this specific bridge stops operating in this way, you can still get something out if this other functionality exists, which in the ideal situation it does. So I think the social consensus is very true technically, but most of the time you're going to want to not have to get society to agree on everything, because that's pretty tough.
Yeah.
So
yeah, there's a lot of coordination that goes into consensus. Okay, so zooming out a little bit and then thinking about, like, from what I've seen, there's two popular mental models when we think about kind of like this map of networks that are out there, and the escape hatch, I think, points a little bit more towards the layered approach, where you have the layer 1s, the layer 2s, they roll up. You can sequentially imagine this paves the way for layer 3s, 4s, 5s, all rolling up onto the lower numbered chains that are kind of closer to the layer 1, essentially. They all roll up and flow down the stack.
Yeah. And
then there's the modular approach. And this is kind of like not a layered hierarchical approach. It's more just like these roll-ups operating in space. How do we reconcile these two mental models?
That's a good question. I've spent some time thinking about the more modular approach, but I guess I'm more of a classical roll-up person where I get this layered model of things on top. That's not to say like other types of roll-ups, like sovereign roll-ups or enshrined roll-ups or whatever you sort of want to consider as a more pick and choose type approach aren't useful or helpful. But I don't know that they need to be strictly disjoint in the mental model either, right? You still could envision a roll-up with different layers, except now it's sort of like your layer 1 is fragmented because maybe you're settling on Ethereum, but your data availability is going somewhere else. That still sort of implies that there's some level of hierarchy to me. Maybe it's not quite clean. Maybe it's more of a sort of a acyclic graph that sort of works out. I don't think you should probably have circles there. It's probably going to go bad. So I think there is some way you could actually, get that hierarchy to be kind of consistent, but it is probably less clean. So, I don't think it's super problematic, and I'm not giving a very precise answer because I'd have to go like really define these terms and figure out what we're talking about in terms of modularity and things like this. But I think for now, we're sort of fortunate that we don't need to be super concerned about it because, layer 2s are just coming online. Like they're pretty new in the grand scheme of things. And layer 3s are still very much new, right? I don't know of anyone actively using a layer 3. I could be wrong. But it seems like people are just getting layer 2s to a point where everyone's really comfortable using them. And until that block space, gets full, or until you have very specific app needs, layer 3s and app chains, are engineering for the sake of engineering, and I'm not strictly against that. It's just that they cost so much to develop that maybe they're not worth doing right now. And I think we've seen that. Like again, unless you know of any layer 3s, I don't.
Well, I've seen their projects take this app chain approach. I'll name drop a few. Maybe we'll scrap these out of the written piece later, but ZKX is a perpetual DEX on Starknet.
Yeah.
They announced their app chain in the last couple of weeks. There's SX Network, which is a decentralized sports book rolling up onto Polygon, like a Polygon sidechain. They consider themselves a layer 3. So we're seeing kind of like this app chain thesis, and the piece of context that I want to bring into this, and then definitely keen to hear your thoughts, is that this app chain thesis may end up providing revenue and value because you are able to drive revenue from MEV and the ordering mechanism.
Yeah.
But that takes there's startup costs associated with that. So,
So yeah, I mean, I think you raised a good distinction there, which is like the app chain as a specialized type of layer 3, which I think makes a lot of sense because you probably occasionally want really fine-grained control, right? If you're running a DEX or a sportsbook, these types of ordering things probably matter a lot to you, and you want to make sure they're done in exactly this way and very quick, and users can respond as quickly as possible to it. Like, there's low latency in these systems. That's what you want, in part. And for the app chains, this makes a lot of sense, right? Because then you can optimize that specific functionality, whether that's on the technical level of performance, like if you choose the right layer 2 to build on, or the sort of UX of like, well, look, we have our own wallet because this is what we need, or something like this. And you have total control and total customization. So you can optimize the technical end or the user experience end, or both. And that would be something that's going to probably make a lot of sense for a lot of domains. Like even gaming, I think, is going to come, or you're probably going to have gaming app chains because you want to have your game be as performant, I think, as it can be. And to do that, you want some level of its own chain, but you also want, a settlement layer that is universal and well trusted. And so a nice layer 2 is definitely going to be there. The general layer 3 is I'm less sold on right now as a need. But yeah, so the app chains will come up. And you're right, there is startup cost. I mean, I think there's a lot of effort to make that work. But if you have a good enough use case, it's worth doing. And with the right underlying layer 2, like a fully developed ZK layer 2, you could definitely get good performance and good finality time, like withdrawal finality, so that even if you have users who are not expected to be isolated on your app, you can still get them to bridge through Ethereum relatively quick. Obviously not necessarily instantly if they have to go all the way sort of down to the layers and back up, but you could get this to work quite well. So the app chains make sense, and there is going to be a cost, but I think for a lot of people it will be useful. What I'm not I don't know if I've said this already now, I'm not really sold on the layer 3s as general, like just putting like another Starknet on a Starknet, like that's cool, but sort of why? I don't quite see it just yet. It's nice that it's technically feasible. I think that's really, really cool. But these other use cases, yeah, you're right. I think that's where it'll come through, where you have very clear incentives and you want control. And we're going to see a lot of those. But then I almost wouldn't consider them layer 3s. Because to me, it's sort of a real layer is a layer that you can build on top of. And so unless your app chain is also building a framework of some sort of programming language, like you can't build on top of it. The layer ends there. It's the end use. Okay. So in which case, it's almost indistinguishable if you squint your eyes, from just a smart contract app. It just happens to have more off-chain components, which, complicate the engineering process and hopefully for the right reasons. That's either incentives for the project or usability and, good experiences for the end users of these apps.
Very cool. I think this has already expanded my horizons. So anything in general that like, I don't really have any other specific questions. So just kind of like based on your experience diving really deep into this subject, what are anything else that you think is relevant like for this conversation?
Let me think about it for just a second here.
Yeah. Just in general, really, just any thoughts you feel looping in?
Yeah, so I think one thing that I think will be very interesting to see is some layer 2s who sort of deviate from the norm in terms of this EVM equivalence in order to get better support for these things like app chains, right? Like layer 2s that support programming languages that aren't necessarily Solidity, for example, will do a really interesting job of this. I say interesting because it could be very good, it could be very bad. But I think it's most interesting not because of its technical sort of challenges. I'm sure there are many. And I think like there are projects doing this, and Cartesi's doing like Linux on the blockchain and things like this. The real interesting part there is because they actually give an opportunity to onboard a whole bunch of like Web 2 developers, right? There's so many developers working on the Linux space, and I'm sure Ethereum's, captured some of them, but there's going to be a lot more if you can capture even more. And it doesn't have to be just Linux. It can be whatever other language. So for me, my personal thesis is a little bit of like, let's move away from EVM equivalents for the right reasons when the time is right. And for some chains, that's now, if they're willing to take that risk. And for other chains, it's probably not the time. And for some chains, it'll never be the time. That's fine. But that will make it really interesting and kind of scary, because those are going to have a whole bunch of different security assumptions and implications. Like, people are going to assume that their programming language works maybe exactly the same way, and maybe the semantics will change. Maybe they won't. It'll depend on the exact implementations. But that will be a very interesting day when we have, Ethereum conferences, and not everyone is necessarily a Solidity developer. That's not true now, right? You have some Viper developers, you have some other language developers, like people who just go right into Huff and low level stuff. But it'll be really interesting when you see a ton more developers who are building in different languages, and then you'll get to see a lot of really cool tech and stuff, where you'll have like new support for crypto primitives you don't currently have, and so things will get more efficient, things will get more cool. There'll probably be a bunch more hacks. That's that's the reality. Like when you build so many things and there's so much money on it, people are gonna find ways to exploit bugs. That's scary. Obviously, I don't want that to happen, but the reality is I think it's gonna happen.
And is that the reality of building aside from EVM equivalents? Like if you're building something unique that's not based on this pre-existing framework of the EVM, then it's more likely that you're taking security experiments almost.
Yeah, experiment might be a little bit too strong. Like, I don't think anyone's out there really like rooting for people to lose. It just, sometimes things don't work out the way you wanted them to, or you forget to write your code properly in some cases, and it doesn't break out. It is kind of an experiment. I think that the word might be a little harsh, but yeah, but it's for the right reason, right? It's not a literal experiment, so you're not, it's not an ethical violation to sort of do that. But but maybe not, right? You could also envision a world where it's simpler, right? This is sort of what the app chains are doing. But like if you really hated Create 2 or Create, you could cut that from the EVM, and then it's an experiment, but one with very little risk, because you sort of knew what that chain looked like. It was out there before these opcodes were introduced, or at least Create 2. So yeah, it is a risk, but there's also a lot of reward and upside, right? If everything goes right. So it's one that some people should take, and I honestly think with layer 2s, people should build a little quicker than Ethereum, right? Ethereum needs to be really secure. Ethereum's slow. There's a lot of money on it. Like, it's slow in the sense of building, not necessarily in latency. I mean, it is probably that too, but
L2s.
Yeah. Ethereum has to move slow so that they don't screw it up, because there's too much at stake. On a single layer 2, you probably shouldn't push an update, every week or every month, but you can certainly move more quickly than, one sort of Geth client update per year or 2 years. I actually imagine Ethereum does more than that, but most of them are very minor changes. But you could probably make major changes on a rollup somewhat quicker, especially while you have a low user base. And if you have a good community that understands that what you're doing is something that is kind of experimental and very much, not yet battle tested, because they're trying to do something like this new innovation, they might not even mind. Now, that community probably then won't bring billions of dollars in if they were rational, because you don't want to lose that. But
and it would almost slow them down.
Yeah, it would slow them down. The more money that would bring onto the system, it might be worse. But you as a single app chain or layer 2, even really, you can move faster than Ethereum. So I would like to see that. I would like to see someone building an L2 that sort of destroys the EVM in weird ways that we haven't thought about, like just almost random iterations on like gas code opcodes, just to see what breaks. That would be a useless chain, absolutely useless. But it'd be interesting to see if you could do it technically, and then really like get the community familiar with this notion of you don't necessarily need a rollup that's EVM equivalent. Although you're comfortable with one and you like it, in the future it might not look like that. So that thought experiment would be probably a waste of resources, but maybe a fun hackathon project just to see like what would you redeploy and what would break, and you could sort of make it a sort of a white hat sort of sandbox where you can play around with, oh, would this contract have been hacked if this situation was around? Because then you can use that to guide future Ethereum updates. You can say, look, definitely don't do this, because look, I now have data that says this is going to go bad if you do this.
Are projects staying away from taking those leaps and bounds in their development process because they lose composability with the rest of the EVM?
Yeah, I think so. And so composability is a big feature. It's not something you should totally discard. But when you start to think about composability, which sort of requires transmission through a bridge anyway, so specifically like app chains, who sort of like, to talk to another app, will have to talk to a layer 2. Well, you can have layer 2 composabilities that always have to go through layer 1, in which case, you can still get composability, it just gets more technically challenging to sort of conform the call and during the bridge to a composable thing. And you could have a different form of composability which might be more valuable on your local L2. That's a lot of engineering work.
That piques my curiosity because like we haven't seen the interop and the composability across these app chains.
No, we haven't. And for, they're good reasons. It's technically challenging. The things are not atomic, so there's a lot of like things that can sort of break in this process, whether, the fund just aren't high enough to relay the message, or the message was malformed, or, some other reason, which could just be delay, right? It takes time to get things across chains. But that doesn't mean in the future, it wouldn't be so bad. If it took 20 minutes to get a cross-chain call between two roll-ups, which seems like a high amount of time, to be honest, in the sort of ideal world, that still could be a lot quicker than, waiting for my bank to do it. So even though it's slow, in air quotes here, it's actually pretty fast, right? So for the right reasons, we can do this, but I think everyone got used to like, I'm just going to do it right on atomic transactions, and good. I mean, that does help with a lot of things. You can do probably better like DeFi because everything's more atomic. You don't have to worry about things. But when we move past things that are so time sensitive to other forms of apps, like if you imagined a social network, like popping a like on someone's post doesn't require instant latency. Like you'd like to see it come up there, but for the sort of useful case of the app, if Facebook has a use, it is, not important that happened very quickly, right? It happened eventually. And when we start to see apps that,
influencers would venture, they would probably push back on that.
They would definitely push back. Yeah, absolutely. They want to see it instantly.
They want that dopamine
absolutely.
hit right now.
It'll come. It'll just come later in 20 minutes, right? When we start to see slower apps, more useful apps, not that the current stuff's not useful, just like more of them, right? Literally more of them. I think we'll start seeing a better need for that. And, maybe there'll be other trade-offs, right? Maybe those transactions will somehow be cheaper. And so maybe people will start to question if they need it right away, and maybe it'll, I don't know, now I'm spitballing, and I have no idea if this is technically feasible. So, like, if you're reading this and I'm saying something wrong, just, let me know. Like, I'm happy to discuss it. I could be very much wrong. But it's interesting to see where the future will go. And unless we start questioning about why this is or is not desirable or useful, we shouldn't discard it. And we should keep it open, because for all we know, the next killer app is going to be one where, maybe you need some sort of roll-up to roll-up cross-chain communication. And there's a good reason for that. And you'll either have to deal with this or you'll want to deal with this for some reason. So, I look forward to that future that's technically interesting and challenging. I'm a technical person. I like, seeing where these challenges are, and some of them will probably work out, and most of them probably won't work out. And I'll probably look like an idiot if I read this in 5 years. But I'm happier to look like an idiot now and be proven wrong than to sort of, not take any risks and sort of live in my cushy little world. I'd rather someone say, no, you can't do it, and here's why. Because then I at least learn something, and hopefully the community learns something.
Right. Even doing those, even attempting those hard things and figuring out that you were wrong is still valuable.
Yeah, that's still some level of science. So it's good.
At the risk of overextending this conversation, hopefully this can provide a nice end cap and maybe be the predecessor for our next conversation.
Sure.
We're starting to get into, I think we've laid a nice topology for these roll-ups and talked a lot about kind of the differences and why someone may build a roll-up a certain way.
Sure.
And with that now kind of being out on the table, we're starting to get into interop and composability across these roll-ups. So I want to kind of summarize like my understanding of how we've arrived at this point, and then let you just venture into your imagination.
Sure.
So when we first started to get alt layer 1s and started to even break into layer 2 space, we started to get into cross-chain communication. And early on, this began with, okay, we have a roll-up here. Don't even call it, we can call it roll-ups, or we can just call it chains. We have a chain here, we have another chain here, and the earliest, most primitive forms of cross-chain composability and interop were, okay, take what happened on chain A, pull that off chain, and then go put it back on chain B. Now go into the layer 2 space. What that looks like in practice is take what happens on layer 2A, pull it back onto the layer 1, and then put that from the layer 1 onto layer 2B. Now, when we get into like roll-ups and kind of like even more of these networks, like, do we ever get like a direct path?
I hope so. I don't think I have an answer for you that is definitely yes. I've actually talked to some people and they're like, oh, we can definitely do that. And there's this very weird cryptic way. And I was never convinced that they knew what they were talking about. But, I think people are excited to try it. And I think there are some cases where, maybe that will be very easy and maybe that'll be very hard. Right? So if you could imagine an app chain like that has a game, for example, maybe you could migrate the state of that game to another layer 2 fairly quickly without going down to the layer 1 in some very limited settings. Probably centralized settings right now, but maybe that's one case where it's pretty clear. Because I say game state because game state might not be collateralized, right? So when it's collateralized, it seems like it's almost necessary to go down. Probably necessary because you sort of want the same consensus on what that asset is, and if one chain is just minting it without talking to the collateral itself, maybe that's a problem. But for these other applications where collateralization is less of an issue or non-existent, yeah, maybe you can do layer 2 to layer 2 direct transactions in some meaningful way. I don't know what they look like. Like I said, I've never seen anyone do it successfully. I hope there is research going on that, and I think that would be very interesting if you could do that. So I hope so.
At this point, is it appropriate to reduce to the consensus? Like, it seems easy enough. It makes sense to, if you have something on base and you have another network on the OP stack, you can somewhat collate like the state based on whatever the OP stack says. Like you can make sense of the base and you can make sense of this other network by interpreting like the state of the OP and the optimistic network. So now I actually don't even know if optimism has its own consensus, but at a certain point, what I'm gathering is that we can almost like reduce back to the consensus that those roll-up networks share, and based on what the consensus of that consensus layer says, then we can make sense of like the state of these other roll-ups.
So I'm going to say something that I could be very wrong on. So please include the disclaimer if you put the text in. I think that's what the whole idea of the superchain is supposed to be. Is the optimistic stack will share a sequencer, and you can sort of bridge into a single contract and sort of specify which destination chain. So if they're sharing the sequencer, you can say, well, I'm going to put my stuff on base, or I'm going to put it on Optimism mainnet. And then you can sort of rely on the sequencer itself to be that interop between those two L2s directly. Now, if I am right about that, I think it's still forthcoming in terms of the technical level. I don't think that functionality is implemented yet. Or I'm just wrong and I've misinterpreted the superchain and it won't be coming because I'm wrong. But I think that's the idea. So that would be also interesting. And for the consensus part, right, Optimism's currently centralized. They don't have a decentralized sequencer. So it's pretty, if that is the assumption that I'm correct about this understanding, that would actually be pretty easy to do, because the sequencer could just say a cross-chain thing and then it sort of moves the funds. But because they had the same vault on L1, it doesn't need to sort of go back and talk to L1. Maybe it needs to write some little data somewhere, but I think that's the intent. So I can either get back to you and confirm that understanding, or someone from Optimism who's like, no, he's wrong. He should not be doing that and saying that. But that would be cool. Like if you could do that type of shared system, and then I imagine you can sort of, if that assumption is correct, I imagine you could ramp it up to like 11 by using decentralized sequencers that sort of talk to many networks at once. Because I like the OP stack, but you know, maybe a decentralized system, it can do that even better because you can sort of do more by decentralizing. Like, you know, maybe your version of the sequencer does something different, and so you can do that for more chains because you can add endpoints or something like this. I'd have to look at the specifics, but I think what you're saying is possible and intended, but not yet implemented. I could be wrong.
Okay. Yeah, I'm left with so many more questions than I started with. So this is probably a good place to leave off.
Sure, yeah. I mean, I don't know how much time I was promised or you were promised, but...
No, I came in with no expectations, really. We're at 40 minutes.
Sure.
We could probably transform this and post the entire thing on Spotify at this point. And,
sure, yeah.
Yeah, and like make it into a full podcast. But it is almost like reassuring and encouraging to think about like the value of Ethereum. It really lies in its consensus. Because through this consensus, we're able to make sense of the state of all these other networks and rollups that are built from the Ethereum-centric architecture, which is really like the Ethereum consensus. I'm coming to find out, coming to realize.
Absolutely. It's an exciting time to build.
Yeah, cool.